You're here for View the Ultimate Control Tower from source to consumption. And there's going to be three of us today. So I'm the Senior Advisor for Global Supply Chain for InterSystems. We have Ming, who's Head of Supply Chain Strategy for InterSystems. And we have Frank Blau, who's a Principal Data Architect for Epcon, which is one of our key strategic partners that we have in Europe, specifically out of Austria. What we're going to talk about today is the importance of real-time, actionable insights. And then we're going to show you what we call our ultimate control tower. And the reason why we call it ultimate is because we go more into just not the dashboard of what is happening, but we go into prescriptive, so predictive and prescriptive actions. So that's what we're driving with it. So it's twofold. It's the art of the possible, and we go into predictive and prescriptive insights, so we can make real-time decisions. And then we're going to talk about IRIS interoperability. So we're going to show how the data platform is used from an interoperability standpoint with a continued use cases with a demo. So why is it important that we have actionable insights? And so I'm going to show a short clip. It's only about a minute and a half. It's something that we put together with Deloitte and Association for Supply Chain Management. And the reason why it's so important, as you will see in here, that's where the supply chain is moving. How can we be more predictive and then prescriptive on being able to make real-time actions that have an impact on specific use cases? And you'll see that this use case is really like the one I did at the keynote this morning, on time in full. And as we know, trying to drive on time in full is not easy to do, especially the end-to-end supply chain. So I'm going to click on this, let's listen to it, and then we'll come back.
Command, I'm getting an alert. It appears we have insufficient inventory to fulfill an incoming order.
Production, what's going on?
We're predicting schedule changes due to unplanned weather conditions.
Analytics?
Forecasts show a storm hitting in 24 hours. Social listening confirms the track, and sensitivity models are predicting asset downtime due to flooding and workforce limitations.
Delays in delivery of raw materials could cause capacity loss of up to 26%.
Production, what can we do?
Running alternative production scenarios now. Our best option is to add capacity at the Northeast plants. An overtime shift would meet demand at positive margin impact. The problem is raw material inventory is too low for additional production.
Supply, if we did go into overtime, is there anything you can do to get the raw materials there in time?
Scanning inventory positions in storage and in transit. I've got raw materials on their way, but 5 days out. Wait. There's material in a warehouse we could get there in 2 days if we ship by air.
We've got clear weather on that route and a 150-knot tailwind, which will save on fuel.
We got raw materials in 2 days. We could make the order on time and stay within margin thresholds.
Exceptions. Can we make this call to go into overtime and divert materials?
Verifying this is within our tolerance to make a decision automatically. Command, we're good to go. No need to escalate to the supply chain planner.
Okay, Digital Supply Network. Let's do it.
Okay, so that's what we do, right? So that's what it's all about, and that's what you're going to see from us. And that's the art of the possible of what we do here at InterSystems for Supply Chain using IRIS. And just think about it too, and again, we were talking about this morning, is because of COVID and because of the great resignation and the loss of tribal knowledge, what if half those people that were in that show weren't there anymore? Would that mean that you couldn't do you couldn't do what you needed to do? Most likely, but if you were using InterSystems IRIS, you could, because we're going to show you how we would simulate and be able to provide those prescriptive decision making. And that's really what this is here. So this is a little bit of a launch, is that we know the Indian supply chain is truly from source. We talked about that yesterday in the round table. It's truly the source of going from wherever your first mile is, internationally, domestic. We're moving it through production. Maybe it doesn't go through production, but if it does, we cover in production. And then we go from production to that last mile. So maybe it's omni-channel. Maybe it's going to a distribution center that then goes into the final consumption point. And this is what we're going to show you is that, again, any use case, any metric, I always use on time in full just for consistency purposes. But we're giving you recommendations on what is required to be able to optimize within your supply chain. I'm going to hand it over to Ming, and Ming's going to take us through a demo within manufacturing and then outside of manufacturing and how we can have an impact.
Good. All right. So before I jump to the demo screen, I just want to say a couple words about the control tower. And you heard of control tower in many different ways, right? Most commonly, people know the air traffic control tower. The video you just saw was kind of a control tower for supply chain operations, right? So how many people here think that's still science fiction, the video you saw? Or how many people think that's close to reality today, right? So we're going to show you something that's no longer science fiction anymore. And we are very close to make that reality. And in many ways, by using our technology, our solutions, Iris for supply chain, we can get you very close to almost exact same scenario and how it can help your business. So talking about control tower, I mean, even if you think about the generic one, the air traffic control tower, right? So it depends on a lot of data to do the work, to do the job, right? But it doesn't need to see all the data all the time. It doesn't need to know, each aircraft engine and all the sensor data. But it needs to bubble those things up when something happens. And by the time they need the data, they need to be able to access the data. So same thing in supply chain. We have tons of data, from transactional data, from orders, from shipments, to manufacturing if your business involves manufacture. So think about, I know most people here are not manufacturer experts, but you just can imagine in a big manufacturing floor how many machines are running. And today, those machines are very smart, right? You have robots and things, you have a lot of sensors, IoT devices, there's a huge amount of data being collected from that environment to help you run your plant operations smoothly, to fulfill your clients' needs on the order side. So for that reason, we are showing this is just one of the possible scenarios that we can help using our technology. So on this screen, we're going to start with the manufacturing floor. So assuming this is maybe a manufacturer making, say, combustion engine or something, right? And you have plants in several locations across Europe. And you are collecting data from all these locations, from Darmstadt, Hamburg, Munich, Paris, and all these plant locations about what's going on within each of the plant locations. How many machines, which one are moving without any issues, which one we are seeing some risks or potential failures of any of these things. So we already identify some of the issues. So there's no reason for people to see all the detailed the data that comes in. And if anybody interested, I can show you. For example, this is going to be showing the real time the IoT data feeding in. So you'll see that. It's a live feed, right? But for most end users, it doesn't make much sense. But behind the scene, we're collecting all the data, and then we can tell you how is your machines running, what kind of risk you may have, or you may potentially have some potential risk over time. And that's what really this screen is showing us. So you see here, for example, at this particular location, we're showing unexpected outage. And you see the outage numbers keep going down week after week. And you know why? It's not by accident. It's actually because we are taking advantage of our data platform capability. We are learning behind the scene, and we are trying to predict if something goes wrong, and we will proactively act on it before the machine breaks. So you see these here, the predictive maintenance numbers keep going up because we're doing better job by leveraging all the data we have on our platform. So that's why we can do better over time. And then the actual outage, the number keep going down. But clearly not all factories doing that. So you can see how data can really help your operation. So let's take a look at the particular plant location. And you'll see how many machines are out there and so on. And let's say let's manually trigger some artificial risks that we may be getting. So here I'm saying I see some threat signal coming up whether it's from a pressure sensor, a temperature sensor. It's like you're driving a car, right? When the temperature dial gets into a region, it's dangerous, you better take action. Actually, just a couple months ago, my wife was driving the car on the storage drive in Boston, and then she never saw that the temperature sensor is actually in the red zone, and the car just burned down right in the middle of the storage drive. You know, that's a busy traffic area in Boston. And she's stuck there for 3 hours before somebody can tow the car away. So it's very important that you really need to pay attention to what the signal is telling you, right? And in this case, we are seeing here, the system pick it up. Say, you have a problem. Let's take a look. So this gives you something information about what we picked up from the sensor information. You have a problem, something is going to break down, and you probably have some options. You can order spare parts. Maybe it's not that serious. You can just do a minor repair. So let's say we're going to order a part, spare part. So then we're done here. So what happens is, behind the scene, our business process engine will take over. So we will put a PO to the supplier. We'll order that part that required for the maintenance that need to be done here on this particular machine. And at that point, you know, from the manufacturing perspective, we think we're good. We took the action as needed, the best that we can do at this point, but is the job really done? So from the control tower perspective, no, you're not done yet. Yes, you put in an order, you got the PO out, and you probably will get shipment from the supplier soon, but will that supplier shipment get to your planned location in time for your maintenance? And that's when we will switch gears here. So we were looking at manufacturing. Now let's look at from the logistic transportation perspective. So the order was put into ERPs, it's sent to the supplier, and the supplier fulfilled the order, and then the shipment is on the way. And unfortunately, because these days we all know how much disruptions we have in our supply chain, and something happened. And we also have a predicted model using our data platform that we know when something happens or when you ship certain things from one place to another through whatever carriers, through whatever transportation mode, we can predict how certain things can happen. And that prediction doesn't have to be based on historic data. It can also be based on additional external event information, the weather information, other things. So in this case, there was a local shutdown due to COVID event. So our parts been shipped. Somewhere in the middle got stuck somewhere because of the COVID closure. So our system picked it up and predict this thing is going to be late, even though the carrier haven't said anything to us yet. So we actually raised a flag on this particular shipment. So this is a shipment going to dump stock plant here, right? So it's supposed to be there at some time, but we know it's going to be late because of the COVID shutdown. So what do we do now? And our data platform can actually bring all this information together, right? We talk about some of the machine learning model, predictive analytics, and so on. So we can run some analysis to understanding what might be the root cause and what's the impact. What's the impact on my business? In this case, we kind of know what's the impact because one of the plant machine is going to be broken if we don't do something. We don't do the maintenance service, right? But after it's almost very similar to the video you saw earlier. After we put all these data points together, we are seeing there's not much we can do about this particular shipment because it's a custom-made part from a particular supplier. We don't have an alternative secondary or another supplier who can do the same thing, provide the same thing. So we're stuck with kind of this particular shipment. Say, we know it's going to be late, but in a short time, I don't have an alternative approach. So if you're just looking at the shipment, you're like, I'm stuck. What can I do? What can your control tower help us? So we say, OK, assuming it's going to be late, what's the impact, right? If that thing is not here, we either, the production machine shuts down, or we just wait, leave it idle and wait for the parts, do the maintenance. And what's the impact by doing that? So it goes through all this input information that we have from one side of the supply chain to the other side, And it turned out that if we don't do the maintenance on time, we'll have a couple of sales orders that our customers are waiting for, which depend on these machines at this plant, is going to be delayed. So, and because I cannot do anything about shipment, I will mark these 2 orders. You have a problem. Both of these orders, you have a problem. And you will not be able to be fulfilled on time due to this situation. So the system automatically fixes it. Nobody's doing anything. No manual step involved. System automatically trigger it, have issues created, and attached to those orders. So at this point, if I'm someone in charge of on the customer care side, and I'm looking for after all these orders, I see my order here. There's some actions waiting for me to take. So this is what waiting action is about. So let's take a look. So this is one of the impacted sales order. So I know the root cause, our order impacted by delayed plant maintenance due to a late shipment of parts. So we know what caused it, right? That's how this issue got triggered. And we also know the root cause, everything. And if we don't fulfill this one, this is a strategic customer. We don't want to risk any customer satisfaction issues. We really want to help to see what can we do to fulfill this order on time for this particular customer. So the system will go through additional analytics that needed to be done by combining all the data, different processes. We'll look into manufacturing side, we'll look into logistics side, we'll look at all different plant locations. So we come up with a few options for you. And the first option is, so you have a problem at the Darmstadt plant. And looks like our Hamburg plant can also do the same thing. And one option is, let's move this sales order to be fulfilled by a different plant. Good. Again, supply chain is so intermingled, right? So if you change something in your supply chain, the impact is never isolated local. So what's going to happen? Yeah, this order will be fulfilled on time. But because you're fulfilling with a different location, you're going to encounter a little bit more extra shipping costs. Not a big deal, right? Not a huge amount of dollars involved. But the key message here is, because of this, we are putting extra workload on the Hamburg plant machines. What that means? That means you better plan for some earlier maintenance windows for that particular location, that particular machine. So that machine doesn't fail down the road, unexpectedly because of you're overloading it. So that's one option. And then another option is just wait for the parts. It will come sometime, right? And then just once the parts is here, finish the maintenance, and then make whatever product it's supposed to do, and expedite the shipment to your customer. So that's the second option. And if you do this, of course, because you're expediting the shipment, you're going to have extra shipping costs. But the key factor here is it's still going to be late. Even though you expedite the shipping, you're not making up all the time you lost due to the maintenance delays. So you're still going to be late. And so that's the second option. The third option is, why don't we leverage spare parts in Munich plants and redirect the current shipment to Munich? So they have some parts seems to be available there, ready for their local maintenance. And let's get that. So we can really do our maintenance at the Darmstadt location and then fulfill these sales orders on time. But if you do that, the current sales order will be done on time. But we are putting additional $250,000 revenue on risk at another location. Because the originally scheduled maintenance is not going to be done on time. And you are putting additional risk on some other critical orders, which is valued over about $250,000. So this is just to give you a taste that supply chain, we have a lot of data involved. I mean, getting the data is important, but more important is to how do you leverage the data to really solve business problems. And supply chain problems is usually not isolated in one side of the supply chain, right? The supplier side, manufacturing side, or the sales side, warehouse, internal logistics, DC, right? It's really, you move one, and the impact can be all over the place. And Frank will show some interesting stuff about graph data. So it's really, you can imagine it's like a graph. And you move one node in the graph, and not everything else linked to it is going to be impacted. And that's exactly what happened in supply chain. So you really need to have a good control of all the data and make them work together and be able to get insight out of it, be able to use your predictive analytics and prescriptive to really help you to find the issues and then take the best actions based on all the information that you get out of your control tower. So with that, I'm going to hand over to Frank.
But that's not what I wanted to show you, so we're going to come back here for a second. So my name is Frank Blau, and I work with EBCONT in Austria, and I'm a data architect, which means I'm kind of a nerd. You can tell because I'm the only one in the room wearing a t-shirt, I think, so. Oh, excellent. Okay, so also nerd. So I like to preface this talk with something that's a little bit esoteric. Raise your hand if you've heard of Marshall McLuhan. One, and you've watched my talk though. Marshall McLuhan was a communications theorist from the 1960s and 70s, and he's very famous for saying one thing. He's really cool, but he's very, very famous for saying one thing. He said, the medium is the message. And Marshall McLuhan was talking about television and radio and that kind of thing. But if you extend that into today, you see very clearly that we're in a world filled with mediums, and we have to choose which mediums we want to communicate a particular message. And so what I did, and I did a talk about this, if you Google me, you'll find my talk about it, is applying this to data architecture. And the lesson from this, for me, is very simple. That structure, that is the structure that you put your data in, is as informative as the content. And what we've seen with InterSystems today is a lot of content. We haven't talked about the structure, though. We haven't talked about how it's stored. And the world that we live in today is multi-model. I don't think there's a single company out there that just has one kind of data. You may have relational data, right? Everybody has relational data, right? You may have time series data. You know, you may have DevOps data, machine data, whatever. But you may also have document data, like your application interfaces that your developers use. And you may also have other kinds of data too that you need to integrate together. And so when I was introduced to InterSystems, I immediately started looking for the things that it didn't do. I wasn't the best partner, you know? I was like, what doesn't this thing do, and how can I demonstrate something? And this became very important to our relationship with InterSystems in that they asked me to say, okay, if you find something we can't do, show us how we can do this together. And I was like, cool, that I can do. So what I'm going to show you today is two examples of integration with what we call graph technology. And graph databases, raise your hand if you've heard of graph databases. They're the coolest thing ever, aren't they? I mean, the thing about graph is, like, the whole world is a graph database. So what you saw in the control tower, I sort of rebuilt this model inside of a graph database. And a graph database consists of nodes and the relationships between them. And to a data architect, this is really cool, because when we used to model things with people, when we were doing like data modeling in class and things like that, we would draw stuff like this on the board, right? Our whiteboards were filled with circles and lines. And then we would go away and we'd go back to our desks and we'd write really cool code about how that fit into a relational database, or maybe how it fit into a data warehouse or something like that. Well, in the graph world, guess what? This is our data model. This is exactly what our data model is. I don't have to transfer that to the world of like a relational database. So what you saw in the ultimate control tower was my starting point of a factory, production lines, a machine supports a protocol, a communications protocol, a machine has some sensor readings, and I was like, okay, but what's not in there? What if there was an MRP context, that manufacturing resource planning context, where we knew where the materials were coming from, what vendors were supplying us with different kinds of materials? What if that context was not in our existing system? Well, in a graph model, it's actually quite simple. a machine, and again, I'm vastly simplifying what you would actually build in the real world, but a machine processes material. And the material is supplied from a vendor. And then you run the data into this model, and you can start asking some really interesting questions. And one of the things about a graph model that you don't get from a relational model is you can look for patterns of things. I can say, show me all the things that look like this across billions of instances of all these nodes. It's possible to do that in a relational database. It's not impossible to do it. But if you've ever tried to write, for example, highly recursive queries, and one example would be if you think of LinkedIn, your friends, your contacts, and then you want to find, yeah, but who are the contacts of my contacts? And who are the contacts of the contacts of my contacts? Anyone here ever tried to write a SQL query like that? Yeah, you go 3 levels deep, what happens? It just stops. You know, these are the kinds of queries that do not function well in this world. In a graph database, billions of nodes, those kinds of queries are still at the sub-second level. Very, very powerful way to analyze your data. But I took this simple example and I ran it through a graph, put it into a graph database. I kind of just extracted the data from the control tower example and invented some data about materials and vendors and what those relationships might be. Now, just so you know, the data that we're looking at here is data that was external to the control tower that I brought in to say what would happen if you could analyze them together. And I hope I don't need my glasses to do this. There we go. And I'm using a very traditional tool to do this with, which is also interesting. I'm using Power BI, which is a kind of an industry standard analytics tool, looking at the results of this analysis. And this part, I think I am going to need my glasses for. It's an age thing. So you notice that in the control tower, I don't know if you were looking closely at it, we had different kinds of machines. And we didn't have the materials, but we did have locations and machine IDs. So now I have this context in here, and I've married it together with the materials and a vendor context. And the value here is in doing root cause analysis. So let's say I'm looking at, in this case here, the relationship between pressure and vibration across my factories. I have a whole bunch of sensors, and I'm like, there's something going on here, right? If you were a data scientist, you'd be looking at this and you're going, I think there's something going on there. What is the root cause of what's going on there? And I can say, well, let's take a look at a particular type of machine. Let's look at a robot, an industrial robot. Well, we kind of see a little bit of a drop off here, but we don't really see any really strong correlation there with the vibration data. So let's keep investigating. Let's take a look, for example, at a deburr. A deburr is a machine that takes spare metal off of parts. And here you start to see that correlation a lot stronger. Again, it's a root cause analysis diving into the data because we were able to marry together a graph context with the relational context inside of InterSystems. And now I can say, well, okay, the control tower didn't know anything about material types, but I created some aluminum, maybe some steel, titanium, and I can start looking for those relationships in the data here in real time to analyze this. And then I can say, let's pick one. I forget which one actually looks better than the rest. So just a little side note here, the data that I used to do this with, I didn't want to just use random data because then what would we see here? You would just see random noise, right? So I'm a total nerd. I actually have 3 weather stations running at my house that all generate data on little Raspberry Pis. And I'm actually using wind and barometric pressure data at the minute level to demonstrate correlated data. So just side note from a nerd. And then I can look at different vendors and say which vendor, for example, has these anomalies here for this root cause analysis. And this is an example of taking the InterSystems context, using interoperability, which was actually super easy to do. If anybody wants the nerdy details about the interoperability, come see me. I got tons of code for that kind of stuff. It's actually very easy to do. And bringing it back together. But this is just one example of interoperability. I want to give you just one more that I've been working on this past couple of weeks. It's a different graph model, and I went with something super similar. You can think of this as sort of a social model. I have a person who lives in a city, a person works at a company, and they work on projects, and they're friends with. This is sort of the bare bones example we use to demonstrate graph data all the time. But it did something a little bit different. I populated this with data inside of InterSystems. I stored these relationships inside of InterSystems as relational data. So Frank lives in Dornbirn. Frank works at EBCON. These are what we call triples. They're just a simple way of demonstrating graph data. Frank is friends with Diogo. Fernando is friends with Frank. Basically creating all these different triples in the code. And then I took these codes, these triples, and I put them into my graph model. And I'm going to show you what that looks like here. Because I can now explore my graph. And I can say, let's start with just one person. Okay, so here's the people that you saw. And I can say, here's Frank, and here's all the things about Frank that I know. Frank is friends with, Frank is friends with, Frank lives in, Frank works at. Yeah, but what about who else works at? Okay, all these other people work here too. Now I see a relationship, I'm starting to see some relationships pop out here about people that know Frank, but they work with and friends with Diogo. Well, what does Diogo do? Oh, Diogo lives in Vienna, for you non-German speakers. Who else lives in Vienna? This kind of analysis, and I want to bring this back to the Marshall McLuhan thing about the medium is the message. This kind of analysis doesn't happen from just looking at relational data. This kind of analysis is particular to graph. And not only can you look at this and go, okay, I see some interesting relationships there, but I can write what are called graph algorithms on top of this to say, for example, who are the people who are 1 hop away from me? Who are the people that are 2 hops away from me? Of the people that are 2 hops away from me, which ones live in a particular country? And if you start thinking like this, if you start thinking about structure in this way, we're no longer just focusing on content now. We're thinking, if I reorganize my data into these patterns, I can get an analysis out of it that is not available at any other ecosystem that I currently have available to me. So what I did here, and this is really cool, I did it in kind of a, let's just call it a hacky sort of way, because I didn't really have a lot of time. And when I came to the conference this week, I spent some time with Guillaume, who's the author of the embedded Python stuff, and it blew my mind, and I felt horrible. I was like, how can I demonstrate what I did to people who know what Guillaume's capable of doing with Python? Because it's so much more beautiful than what I wrote. So I kind of promised myself I was going to go home and rewrite my thing. I was going to try and do it for today, but everyone told me not to, particularly my boss. He says, no, don't mess with your demo. You're going to break everything. But I ran a graph. I created a graph query that again, it's the kind of query that you would only do in graph. And that is, show me everybody that's 1 hop away from me and give me a count of those people. Give me a count of the people that I have 1 hop away from me. And again, there might be ways to do this in a relational database if you had a pretty complicated relational structure, but this is the kind of thing that happens at scale in an interoperability with the outside platform of Tiger. But that wasn't enough for me. I was ambitious. I said, this is kind of pointless unless I can also get this data back to InterSystems also. Interoperability is not a one-way street. Interoperability means I can analyze data that's in InterSystems using graph technology and take the results of it and put it back into InterSystems. And that's where the embedded Python stuff comes into play. In the embedded Python world, I have access to all the things that you can do in InterSystems. all of the productions, the business objects, the processes, the rules, all that kind of stuff is available in Python libraries. But guess what? The outside world is also available in Python libraries, including the graph database. So what I did was I wrote this, and I don't know who actually cares to see it, but this is my ugly Python code here that desperately needs to be rewritten. But it basically, I took it and I said, connect up to my InterSystems instance, write a query, get all those triples out of my query, put it into my graph database as all those graph objects, then execute that one-hop graph query on the graph platform and take the results of that and bring that back into InterSystems. So now you have the ability to do this analysis and bring it back in, and that's exactly what I did. Because if I go back here now, I ran the query, where's my history here? I put it into a table called persons. Yay, it worked. So now you can see from my model, and we could go back and count them if you really wanted to, but Fernando has 4 connections, Frank has 3, Diogo has 1, Alex, I'm sorry, you have no connections, and Steve has 3. So this is an example of taking graph technology, taking content from InterSystems in real time, processing it, and pumping it back into InterSystems as a model. So what you've seen here is a couple of things. We live in a world where we cannot exist in one ecosystem. We cannot exist where everything is in one ecosystem. It's a multi-model world. And the multi-model world requires interoperability. And this interoperability is really available on this platform. You have to do a little bit of nerdy stuff, but I like doing nerdy stuff, so it's okay for me. But it is possible, for example, let's say my graph was available as an API. I could actually execute the API through the API manager inside of InterSystems also. So there's a lot of ways you can interact with the outside world and get this rich insight that may not be available if you're only looking at a single part of one platform. So that's my demo, and I think we want to open it up to questions if anybody has any about this crazy demo that I did and how you could get into that world. I'd be happy to take questions if anybody has any. Any questions in general? You can ask main questions too, actually.
So applying this
Yeah.
as an example to the supply chain. So applying this to an example of the supply chain would be, let's say, instead of people, could be routes or highways or streets or et cetera, or even different freight forwarders, et cetera. So that way it can actually calculate those relationships. And of course, those relationships can then also have attributes of dollars impact, right? So then when you decide to actually see the top rated options, that's how you can be able to get that impact in aggregate.
Absolutely. But there's one thing that goes on top of that too. So what we're describing here is using a graph to do like a route model. And that's a very common use for graphs, basically, because that line between the two routes could have attributes. It could have time. It could also have cost. It could have all these different things. You could say calculate the shortest or the cheapest route for me in real time. But the other thing you get from graph databases is when you query them, you're not just querying content. You're querying patterns, again, structure. You're saying, let's say, a better example, a more understandable example might be purchasing patterns on a website. Let's say I go to Amazon.com and I'm going to buy something, and I go page A, page B, and then I check out page E. A, B, E is my pattern. And over time, people realize almost everybody does A, B, E. And then they start seeing people who do A, C, E, right? And you're able to query it as that pattern, not just as individual discrete things. You can say, who looks like that? And of course, the kinds of queries you can write, your machine learning people and your data scientists, they love this because this gives it to them in a really digestible way. I can say, how far away are they in the patterns? How far away from each other are they in the patterns? Are they so far away that it's totally an anomaly? Or are they far enough away that maybe it's just a slightly different behavior? And you can quantify this in this technology also. And again, because you have the ecosystem of InterSystems with all the content in it, it's really easy to push and pull from these other technologies to get that kind of analysis. And then the results are easily available in things like Power BI and stuff like that for analysis, as well as native in the platform too. I just did Power BI because I could. But that's sort of what I show is that you can actually do this outside connectivity piece and bring the stuff back in for those answers. Super cool. Any other questions? If anybody actually, if there are any nerds who actually want to see the code, I'm happy to show that too and share it around. So.
And also, if anybody interested to see a deep dive in the demo, we will be setting up something outside.
Yep.
Feel free to stop by, and we can continue that conversation there.
Okay. Thank you very much. Thank you very much for your time, and hope you enjoy the rest of your conference. And if you need tips on things to do in Seattle, you can come see me too. I'm a native, so thank you.